The first question is, why do we need chemical deicers to help with our snow and ice removal operations? The first response would fall into the category of economics. Deicers assist the application of sand aggregates by allowing them to set into the snow and ice. This increases traction for the traveling motorist and reduces traffic tie-ups due to accidents. Sand applications are reduced up to 1/3, which means lower equipment and labor costs. The chemicals also expedite the removal of compact ice and snow by breaking the bond between the pavement and the ice. Snow plows and graders then can remove the ice with less effort. Public pressures also place demands for a higher level of service, and deicers help give the results requested. Chemical deicers are an important tool for compact snow and ice removal on bridges. Sand cannot be used on some of the structures due to plugging of bridge drains and jamming of expansion joints. Deicers help remove ice and snow from bridge structures where storage is a problem. Liquid deicer products such as Freezeguard plus PCI help remove ice from bridges where steel grates cannot be deiced with granular deicers. In many areas of the country, salt is the chemical deicer of choice. Salt is readily available, initially inexpensive, and easy to use with satisfactory results. Unfortunately, salt is highly corrosive and is evidenced by the $10 million spent annually for bridge repairs and replacement. Corrosion to autos and other heavy equipment are other reasons for non-corrosive deicers. In some parts of the country where salt is used heavily as a deicer, cars are rusted out within a 3-year period. These examples show the need for non-corrosive deicer products. The Washington State DOT has been testing alternatives to salt since 1982. We are the leading public agency in the country as far as testing of salt alternatives. Washington State uses less than half of the salt amount that was used 10 years ago, and our goal is to eliminate corrosive deicers completely. Shown here are some of the deicers that have been introduced for testing since 1972. Many different types and formulations of non-corrosive deicers are submitted to the Washington State DOT for testing and evaluation. The first step in this process is to see that the chemicals meet our rigid criteria. Tom Wyman, industrial engineer for the Washington State DOT, has been supervising the chemical deicer testing program since 1982 and has established basic minimum requirements for all deicer chemicals submitted for testing. These requirements must be met before products are sent to the lab for corrosion tests. These requirements include a material safety data sheet, which must accompany each sample before testing begins. The product must be determined to be environmentally safe and non-toxic. The material must be non-corrosive and easy to store and handle. We must be able to apply the material with our existing equipment. Based on WSDOT lab tests, the product must have corrosion values of less than 11 mils per year, adjusted to 0 for distilled water. The material must be non-caking when mixed with sand in different proportions or when exposed to water, and the product must be cost-effective. If the products fulfill these requirements, samples are submitted for testing at the materials lab. Lab chemists are shown conducting the corrosion rate in mils per year test. All deicers are tested using nationally accepted test standards. If the chemicals pass the required 11 mils per year criteria, they are then tested for both freezing point depression and depth of penetration. After the results of these tests are evaluated, the materials with the best results are designated for field testing. Based on results from field tests, we may reformulate, with permission of the manufacturers, the products in our lab to better serve our needs. We then transmit the results so they can improve their product. This has happened with both Great Salt Lake and Cargill products. These products were chosen for field testing during the 1988-89 winter season. Many different methods were used to mix products in the field. Chemicals were tested at ratios of 40:1 to 1:1 with the granular products. Crews in the field were encouraged to try different mixing methods and ratios to expand the test results. The Walla Walla crews are mixing Qwiksalt plus PCI at a ratio of 20:1 and 10:1. Their mixing technique involved spreading the sand and layering Qwiksalt evenly over the sand. Material was then turned several times with a road grader and then loaded into a dump truck and hauled to stockpile. This method gave a very thorough mix, but required a large area for mixing. Shown here is a CG90 straight chemical mixing done at Coeur d'Alene, Idaho. Cargill utilized a hopper-type scales to weigh the ingredients and a cement truck to thoroughly mix the product. Tom Wyman, industrial engineer for the DOT, monitored this mixing procedure to assure a quality product. Crews at East Sela are mixing CG90 at a ratio of 30:1. 6 equal piles from a single 2 cubic yard loader bucket of CG90 are placed along the face of the stockpile. 5 equal scoops are taken from each location, loaded into a dump truck, and then dumped in stockpile. This method appeared to give a thorough mix of product with sand. Freezeguard plus PCI was mixed at a rate of 30 gallons per cubic yard with volcanic red rock. This volcanic red rock is found in the Goldendale area and is very porous, allowing for easy chemical absorption. Product was applied with a Roscoe oil distributor to a pad 60 feet by 70 feet by 1 foot thick. Material was then further mixed with a road grader and then placed in stockpile. Tests were conducted on Sadus Pass during heavy snow and ice conditions. The results were favorable with temperatures in the low teens, with evidence of bond breaking between ice and pavement. Quick material penetration into the ice was apparent within 5 minutes. Straight liquid Freezeguard plus PCI was applied with DOT herbicide spray units on some of our bridge decks at a ratio of 63 gallons per 12-foot wide lane mile. Melting was apparent within 5 minutes after application, with temperatures down in the low teens. Sand stockpile freezing is a statewide problem. Usable stockpiles have been maintained at a ratio of 30:1 with corrosion-inhibited deicers. Temperatures have been recorded down to 0, and sand is still pliable. No one likes to break frozen sand chunks from a hopper sander during a snowstorm at temperatures of -4 degrees. Valuable time is also saved at the stockpile site by preventing unnecessary handling of frozen aggregates, and less area is required for stockpile storage. The Vancouver Division of District 4 had very good results with Qwiksalt plus PCI mixed at 20:1 in their stockpile at Washougal. This ratio kept this stockpile workable during the cold weather when their other stockpiles were frozen and unworkable. The 20:1 to 10:1 ratios have given the best results for de-icing purposes in the lower temperatures. Both the Cargill and the Great Salt Lake products have magnesium chloride added in their formulations to give added de-icing at lower temperatures. In areas where freezing rain is more of a problem, the magnesium chloride allows sand aggregates to penetrate the ice quickly, preventing vehicles from blowing the sand off the road surface. Better results may be gained by applying chemicals at the beginning of a storm before compact ice can build. Ice bonding to the pavement surface is delayed, less chemical is needed for reapplication, and snow removal efforts are reduced. The Spokane Division of District 6 was salt-free last winter, using Qwiksalt plus PCI at 30-1 in their stockpiles as a general roadway sanding material. They found that the chemical made better use of sanding material. They found that the chemical made better use of their abrasive by keeping it in place longer than without. They also used Qwiksalt plus PCI and CG90 mixed at stronger rates for a de-icing mixture. Favorable results were obtained by using the new deicers, and the use of salt was eliminated. As of June 1989, further purchases of salt for use on Washington state highways has been banned. This policy is consistent with legislation proposed in 1988 to ban the use of salt on any state or interstate highway in Washington. District 6 was committed to using non-corrosive deicers before a ban on salt. The Washington State DOT will continue research for better deicers that give the best service to the traveling public. With the increases in traffic volumes and the demand for a safe highway system, chemical deicers are a tool necessary in the future highway maintenance program.